In our country, the standards of water quality are set by the state and the federal government, the EPA. How much of this can be in water that's safe, how much of that can be in water that's safe, and so on. All these little critters you see in pictures up here are interesting critters that are not good to have in water. Some of these up here you all have in you already. They're just part of our digestive system, by the way. I'll mention a few, but before I do that, here's some things that are in water. You know, not all water is pure H2O. Depending upon the rock and the terrain and so on, it's going to pick up calcium or sodium or whatever it may be. Like up in northern Wisconsin, from my hometown, there's a lot of iron in the water. Stains the sink, stains the toilet, stains the bathtub red. Out here in Hays, Kansas, there's more calcium and bicarbonate. It's a kind of harder water. Now you can put filters on your systems, you can have a water softener on your system to get rid of that hardness. But things like sodium Na, calcium Ca, and so on here, chlorine, SO4 sulfate or bicarbonate HCO3 or iron Fe, they're not harmful. It's okay. Strict standards on that aren't too bad. You don't want these things in your water though. Lead, which is Pb, selenium Se, Cr chromium, As arsenic, Hg mercury, not good. There's a longer list than that. These are just some of the common bad things. We don't want that in our water. Well, if we find it in our water, we have to shut our wells down. Change. Each of you in this room has this in your intestinal system, part of our digestive system. Escherichia coli, okay, E. coli. Some of these littler critters up in here, I think this is E. coli right up in here. Here's some things you don't want to encounter. Giardia lamblia. This is the genus species name. Giardia lamblia. I have a long story I could tell you about it, but I won't. I encountered it once during field camp and got really, really sick. Here's a little Giardia up in the top right-hand corner. I can just see that now in the next new sci-fi movie. Anyway, here's some Giardia in the bottom right. You want to kill those things off. You want to filter them out. You want to boil the water to destroy those organics. You don't want that in there. Here's a new one on the block. Cryptosporidium. Now I could go on and on about certain kinds of chemicals or biological things that are in water, because right now it's a good time to talk about it. Cryptosporidium doesn't work well against certain things. You really got to boil the water, but since the 1990s that one's come in. Iodine doesn't kill that one. If you're a camper and use little iodine tablets, that won't work. And the reason why we're concerned about it is more recently is this, you know. And when I say terrorist, it could be anybody. Somebody's got a bone to pick with somebody, a neighbor. I guess you don't want to classify your neighbors as terrorists, but some people can do dumb things. Sometimes they're accidents, but certainly if it's a purposeful thing, that's not good. And you see here in Hays, we've got money. We put new fencing around our water treatment plant to protect it. You can still probably heave something from the road in, I suppose, or the dirt road. So here's a picture, a kind of a mixed bag of all kinds of ways our groundwater gets polluted. And you could think of them, from gasoline spills and chemical spills, and you see it in the news all the time. It soaks underground. And it's our job to find it, detect it, clean it up, monitor it after the fact, and make sure it stays clean. Well, my advice to you is, when you start buying property for whatever you're doing, hopefully be on the good side of the issue, but certainly remember that phrase, caveat emptor, or caveat emptor. What does it mean? Let the buyer beware. You're the buyer. Caveat emptor. Let the buyer beware. Remember what you're purchasing. We'll look at some landfill and dump sites here probably in the next lecture. I may say a little bit about the Hays area, but more so on water. Here's a new word for your vocabulary, leachate. In the environmental area, we like to use the word leachate to describe a pollution plume of some sort. Things that leached out of something. And in this picture, it's leaching out of a landfill where we put our garbage. We bury it. When I was a kid, they burned it. We'd go out to the dump and shoot rats. And then they started burying it because it was out of sight. And then we realized, oh, it's leaking into the groundwater now, so now we got to clean up the groundwater. if we better make sanitary landfills. I think that's kind of an oxymoron type of thing. There are some pretty good landfills out there. Don't take my word for it that there's hardly any pollution at all coming out of them, but they'll age. Okay? So if you want to build one of these things, you want to try to build it over a sandy area that got a certain kind of movement rate, that porosity, permeability, to clean them up. Sand's the best for cleaning plumes, for certain kinds of plumes anyway. It doesn't clean up everything. There are some kind of chemicals out there that nothing's going to clean them. We have to go clean them and change the chemistry. Get it out of there, burn it, alter it, whatever, incinerate it. Bacteria is helpful for certain kinds of sewage spills that can take place. Nature can clean things up, but if we overexceed its capacity, it's not very good. In Hayes, I remember in the 80s and 90s, they were digging up all the old gasoline station tanks that were getting old and leaking gasoline into the ground. Here's one of our Fort Hays State graduates installing a monitoring system out here on 8th Street. An old this is the gasoline station here. They've since put in a little detector building that they're venting off the gases into the atmosphere. So they keep going back and monitoring. It's getting better, getting cleaned up. Good, we're taking care of it. It won't be there anymore. I don't know if this cartoon will kick in right now. There's supposed to be a little animated GIF to introduce this acronym to you, DNAPL. Write down DNAPL. And I pronounce it DNAPL because it sounds like an apple thing, okay? That barrel up there was supposed to have a big blotch of red junk come oozing out of it and soak down around there and eventually go into that well. Well, DNAPL is a type of carcinogenic or cancer-causing stuff that was used in dry cleaners. Big long chemical name, perchloroethylene, something like that. There's a whole bunch of these kind of chemicals that we've made, synthetic materials that we used to clean or whatever. What DNAPL stands for, which you do not have to memorize in here, is dense non-aqueous phase liquids. The key thing is they're dense, so what are they going to do? They're going to sink down towards the bottom. And where do we tend to put most of our wells? Deep down. And that's where this stuff sinks to. This isn't good. There's its fancy name, perchloroethylene. We nickname it PERC. PERC. Remember for this class that PERC, that's its nickname, PERC, P-E-R-C, is a type of bad chemical, a DNAPL. It's a DNAPL. PERC is a DNAPL. LNAPL, L stands for light. So some things will do what? Float on top of the water table instead of sinking to the bottom. So in this picture up here, we've got the water table, so the lightweight stuff would float on top, like gasoline. Gasoline is an LNAPL. PERC is a DNAPL, so that floats down here on the bottom. So we have all kinds of things that we've made. And if you go out in the alley and dump this junk, this is what happens to it. And we've got to find it and clean it up because some of these things are cancer-causing and other causing problems. One of the new critters on the block is MTBE. That's a gas additive. Help make gasoline burn cleaner. Now we're finding out that it's not very good, I guess, in some studies showing that it may be cancer-causing, so we're trying to maybe eliminate this from our gasoline. There's a nickname, PERC. You do not have to write that formula down. If you're into chemistry, you might know that bond there is a pretty tough bond, so it doesn't dissolve too easily and break down on there. BTEX, another type of critter that gets in the ground. BTEX is when gasoline sits underground, it slowly breaks down into other constituents. Butane, toluene, ethylene, and xylene. Again, nasty little chemicals we don't want to get into our drinking water. A lot of communities have a lot of these things in our water. It's just the water and city's job to find them, target them, don't let the water in the supply, and then clean it up. Who pays for it? You do. I do. Through my taxes. By the way, the state of Kansas has done, this is a very busy picture up here, but I use this from a website. Kansas has done really well on being able to target and report and treat MTBE in this state. We're one of the better states in the country to do that, so we're kind of proud of that. Some more other, little pie charts, which you don't have to worry about, but I want you to look at this. There's been approximately 66,000 chemicals made by humans, anthropogenic chemicals, that we use for solvents and so on, that you use in everyday products of your life, that get discarded into the environment. Now, 70% of these have not been tested for toxicity. 2% apparently have been, quote, completely, unquote, evaluated. And then the EPA makes a decision on what to do about that. Now, what kind of tests can we run to see if things have been affecting you or your children? There's a lot of easy tests out there if you go to your doctors. There's, of course, the urine analysis. We talk about the doping going on today with the stuff at the Olympics and stuff. That's a common test. Take sweat, your saliva. These are fairly non-invasive, although maybe frustrating types of techniques. We start getting into those harder tests that give you better data to see what's into tissues or blood samples. This is invasive and it's expensive. You never know what kind of disorders can happen, from nervous disorders to mental disorders to learning disorders to physical disorders that might be from some toxic thing in the groundwater. Difficult to prove, as we found out, just like it's always the argument about whether smoking causes cancer or not. A lot of things to look at, though. A lot of chemistry involved. All right, I've got 1131 here. I'm going to start out a little bit with this diagram. I may have to finish this one. I might try to go and see if I can make it to the end. So please hang in there if I can. I want to kind of divide this up a little bit. Okay? When you get water here, you go back to the dorm, you go out in the hallway and you get some water to drink. It's Hayes' water. Where does it come from? Okay? Where do we get our water from? A fair amount of our water comes from about 15 miles south of Hayes on the Smoky Hill River. These pictures you see, there's a topographic map pointing out where some of these wells are along the Smoky Hill River, and that's one of the buildings that's got a pump in it. It's a well with a pump that pumps it into a line and sends it northward. So you need to remember that about 60% of the water you drink is coming from down there out of that alluvium from an unconfined aquifer. And this is a big issue right now in the politic of Hayes, Ellis County, and people of western Kansas of what we're going to do about getting more water for the city of Hayes. Now there's another river flows through town called Big Creek. Most of the rest of our water comes from this, 40%. Now notice I put approximate on both. I remember in the 80s when there was drought going on that we had to get water from elsewhere. We needed to look for other sources of water. So you need to remember that most of our water comes from the alluvium of these two rivers. Not out of the river, but from the sand and soil and gravel underneath that. Mainly the gravel and sands. They instituted drilling water, they drilled wells about, 300 to 400 feet down into a confined aquifer, into the Dakota sandstone. Most of the water was so salty we couldn't even touch it. However, some of it was not too salty. I mean, you wouldn't want to drink it right away. Very salty tasting, but if we dilute it with the rest of that water, you wouldn't know the difference, and we process that salt out of there. So we have sitting in reserve on the bench, so to speak, about 5% of possible water for the city of Hayes. That's a nice little backup. But if we grow, we're going to need more. So where are we going to get it? Well, we got some wells that got polluted. Maybe we can get those wells running again. So the city invested a lot of money in a thing called an air stripper. It's down on Vine Street. I might try to show you a picture if I get through this today. That air stripper, okay. And it cleans that perk out of there. Getting rid of the perk pollution. 100% pure water after that. That goes back to the water treatment plant. So little by little, we're cleaning up that plume, that perk plume in Hayes, using that device. There were some thoughts back in the 90s. The city spent a lot of money, bought some land along the Arkansas River, out of our watershed, out of our drainage basin. We shouldn't have done it. The state of Kansas says you can't do that. You can't transfer water from one drainage basin to another. Most states have that legislation, yet we spent $20 million to buy the land, thinking we would spend more money to build a 50, 55-mile pipeline and bring it up here. And I know this is being taped forever, but I don't personally think it was a good decision at that time. And it has come to pass that now we're trying to sell the land. We're in a situation, we've got our money back because we've been renting the land and selling the water. So it's okay in that respect, but it was something that wasn't really thought out legally unless we were able, and maybe we would have been, to successfully change the law. Change the Transfer Water Act. So we started looking at the Smoky Hill River closer, south of Russell. Could we work in agreement with the city of Russell? That's still up in the air. Then we thought about Lake Wilson and Canopolis Reservoir. They're pretty far away. A lot of money. You come back to Hayes in 20, 30 years, maybe we've done it, maybe we haven't. We'll see. And of course, Cedar Bluff Reservoir, west of us, was the biggest contentional thing that's been going on and on for a long time. Now, the city of Russell got its state's rights to make the engineers open up the gates to Cedar Bluff Reservoir to flood the Smoky Hill River so they could have water, because they get surface water in Russell. So they got water now. But what gets recharged between Cedar Bluff and Russell? The alluvium. And where is the city of Hayes? Between the two. So what happened to the Hayes' alluvium on the Smoky Hill River? It got recharged. So we got more water in there. So Hayes benefited because of that, even though we're not directly getting water pumped on a pipeline from there. So, you know, a lot of legal things to think about. Watch it in the news. It's going to affect your life forever. And where you live. And if the climate changes, if there's El Niños, or if there's a global warming, or if there's this or that, if there's changes in crops, it's going to affect your life. And like I said, anything you remember about this class, this is one of these issues. So I am going to stop today, and when you come back, we'll look at some pictures of some of these places in Hayes and go from there and wrap it up on the next lecture.